Well, welcome to this online revision session for AQA D1, in which we'll be looking at the June 2010 question 6 on the topic of linear programming. Well, as you can see in this particular question, there is a chap by the name of Phil who is going to buy some squash balls for his club, and there are three types of balls: slow, medium and fast, and it tells you how many of each he must buy. It also tells you how many he must buy in total, how much each ball costs, how much he's got to spend, also the fact that 60% of the balls must be the slow ball, and we're told that X is the number of slow balls, Y the number of medium balls, and Z the number of fast. So in the first part we've got to find the 6 inequalities that model Phil's situation. So looking through the information we're given, we're told that he must buy at least 190 slow balls. So if X is the number of slow ones, then X must be at least meaning greater than or equal to 190. And similarly, when we look at the medium, we can see that Y has got to be greater than or equal to 50. And similarly, Z is the number of fast ones, has got to be greater than or equal to 50 as well. So there's the first three inequalities. We're then told he must buy at least 300 in total. Well, to get the total we'd have to add X and Y and Z together. And so X plus Y plus Z must be greater than or equal to 300 for our fourth inequality. It then says he mustn't spend any more than £1,000 in total. So the slow balls cost £2.50, so 2.5 times X, and the medium ones cost £2, so that's 2 times Y for the total cost of the Y medium balls, and then similarly 2 times Z for the cost of the fast ones, and that must be less than, because you can buy no more than, so it's less than or equal to 1,000. Finally, we're told that 60% of the balls must be slow, so therefore if X is the number of slow balls, that must be at least, that's greater than or equal to 60% of the total number. So we know the total number is given by X plus Y plus Z, so therefore X must be greater than or equal to 0.6 as a decimal, is 60% of X plus Y plus Z. So if we simplify that, we can multiply through by 5, because 5 lots of 0.6 make 3, so that would give us 5x is greater than or equal to 3x plus 3y plus 3z. And taking the 2x, well, that would give us 2x greater than or equal to 3y plus 3z. We could, if we wanted to, also simplify that third one, the 2.5x plus 2y plus 2z, just to get rid of the decimal by doubling everything if we so wished. Okay, so there were 4 marks for this. So we'd get 1 mark for stating those initial 3. We'd get 1 mark for the X plus Y plus Z greater than or equal to 300. we would then get 1 mark for the statement involving the total of no more than £1,000 being spent, and then finally 1 mark for stating the inequality for the 60%. Okay, so that's part A completed. Now in part B, Phil decides to buy the same number of medium and fast balls. So in other words, that is telling you that Y value is equal to the Z value. The number of mediums equals the number of fast. So we've got to show that the inequalities found in part A can be simplified. So we've said that Y is equal to Z, so we can see then that this third inequality will then become just the same as the second one. So that would account for why we've only got 2 of these. Then in part the total x plus y plus z greater than or equal to 300, we're then saying that y is equal to z, so that statement becomes x plus y again, and so we'd have to just show that that becomes x plus y is greater than or equal to 300, and of course the 2 y's will then give you the 2 y's in here. Then the fifth inequality, which would be the 2.5x plus 2y plus 2z greater than or equal to 1000. So we're replacing that one, so that would become 2.5x plus 2y plus 2y again is less than or equal to 1000. So if we double everything in that one, that would then give us the 5x, and then the 2y and the 2y becomes 4y, doubled becomes 8y, and then that is less than or equal to 2000. We're timesing that by 2. The last statement, 3y and the 3z, that statement will then become 2x greater than or equal to 3y plus 3y, which of course becomes 6y. So if we divide through by 2, that tells us that x is greater than or equal to 3y. Or we can divide through by then 3 to give us the statement that a third x is greater than or equal to y, which was the required result in that one there. So for showing clearly what is happening with this one, we get a method mark by replacing the z with the y, and then for obtaining this result again by the substitution and getting an accurate answer for that, we will get an answer mark for that one. Okay. Now part 2, Phil sells all the balls that he buys to members of the club. He sells each slow ball for £3, each medium ball for £2.25 and the fast ball for £2.25, and he wishes to maximise his profit. So in the diagram that we're given, we've got to draw a solution to this problem graphically. So what have we got? Well, firstly we had the fact that x was greater than or equal to 190. So this red line here, this one that I drew earlier, that's the line x equals 190. And so greater than 190 would be on the right hand side of that. So we've got to shade out the piece that we do not want. So we would shade out the left hand side of that line. Similarly, we had the fact that y was greater than or equal to 50, so here is the line y equals 50 going across, and so we're shading out below that line. So this is the piece that will be below here. Similarly, we add x plus 2y greater than or equal to 300. So if x plus 2y is equal to 300, we can have values like 300 and 0, or 0 and 150. So that is the pink line on here. There's 300, 0, there's 0, 150. So we want above that line because it's greater than or equal to 300. Obviously, if we put 0, 0 into this, 0 plus 0 is not bigger than 300, so we shade out again the piece that we do not want. So we shade out below that line. Then we had 5x plus 8y is less than or equal to 2000. So again, the sort of values that fit here would be 5 times 400 would make 2000, so 400 naught would fit. Or we could have 0 and 250 times 8 is 2000, so that's that point there. There's the 400, 0 here, so it's the green line that we draw. Now we want it to be less than or equal to 2000, so the point 0, 0 fits that inequality. So we need to shade the opposite side of that green line, so we shade above it. And that removes that. And then finally, we've got the line y, or the region y less than or equal to a third of x. So if it equals a third of x, if y is 60, x must be 180, so the point 60, 180 would be on this line, and 0, 0 is on this line, so 120 and 360 would be on the line. So it's this blue line here is the one we're interested in. This is the y equals 1/3 of x. Now we want y to be less than a third of x, so for example, if x is 60 and y is 20, if we had a point below that, like 60, 10, then the 10 would be less than the third of 60, and so this is the right side of the line below it, so we've got to shade out above that line as being the piece that we do not require. Okay, just need to make certain that's shaded out there as well. So you can see in here we have our feasible region. Okay, so we need to just put an arrow on there just to put feasible region. It's a piece that's left unshaded. Now we also need a direction of the objective line. Now the objective in this case is the profit, so we need an equation for the profit. Well, the profit is going to be the amount you make on each ball. So we just look back. Originally the cost of a slow ball was £2.50 and they're selling them for £3, so he's making a profit of 50p or 0.5. So if he buys X of them, he will make a profit of 0.5x on those. Similarly, on the ones for Y, he buys buys them for £2 and sells them for £2.25, so he's making 0.25, 25p on those, and he used Y of them. And similarly on the fast balls for Z, he buys them for £2 and sells them for £2.25, so again he makes 25p on each one. Now, remembering that Y is equal to Z, if we simplify this, we get 0.5x plus 0.5y as the profit equation. So we can then decide what sort of values will give you a profit calculation based on this. So the x and the y values, we can see that the line 0.5x plus 0.5y, we can put it equal to any particular value, so we could put this equal to, let's say, 200, and then x could be 0 and y would be, sorry, not 200, make it 50. So if x is 0, y would be 100, and if y was 0, x would be 100. So you can see here, I've drawn in initially an example of a profit line. So this is the profit line for P equals 50. Okay, so that's the objective line that we're required to draw. Remember, we can set P to any value we like in order to draw a profit line. Now we've got to find Phil's maximum possible profit and state the number of types of ball, number of each type of ball that he must buy to obtain his maximum profit. So we now know we can move this profit line parallel and up the page. Initially it will hit our feasible region here, and that will be the minimum profit. That will then hit these two values here and here on the corners, but remember the maximum profit will be at the vertex where this line is pushed as far up the page as possible, and so that would occur at this point here. And that point is the point 320 for x and 50 for y. So to actually work out the profit, we know the point is 320, 50. So if we substitute that in, we need 0.5 times 320 plus, and then the y value will be multiplied by 0.5 as well, so that's 0.5 times 50, and so that will give you a total profit of £185. And in order to obtain that profit, we've got to say how many of each type of ball we choose. So there'll be 320 because that's the x value, so that's the slow ones. Then the medium ones, there'll be 50 of those because that's the y value. And then going back to the original equations, we know that the number of medium and the number of fast is equal because we put y equal to z, so the number of fast balls will also be 50. So there we have the solution to obtain the maximum profit. Now we just need to go back and look at the marking of this. Firstly then, obviously when you're drawing in your lines you need to draw them in accurately, and they must be accurate to within half a square horizontally or vertically at each of the points of intersection. So, having x equals 190 and y equals 50, that's two of your lines, will give you 1 mark. The fact that they go through 0, 150 and they go through 300, 0, that pink line there and there, that will give you a mark. And you've got a line through 0, 250 and 400, 0, that green line would give you a mark. And you've got the line y equals a third x going through the origin, would give you a method mark to start off with, and then an additional mark if you've got it going through 300, 100. In other words, you've got the correct gradient on that line. Finally then, all the regions must have all the lines correct and labelled correctly, okay, with the shading. That will give you a mark. And then a correct objective line will also give you a mark. So that's your 7 marks for the diagram. Then, while having a profit objective equation, that will give you a mark. For obtaining the correct value for the vertex at which the profit is a maximum gives you a mark. For obtaining the correct answer for that profit will give you 1 mark, and then for stating the number of each type of ball gives you 1 mark to complete your 4 marks for part 3. Well, hopefully you found that solution helpful. For more assistance with your maths revision, please go to the Further Maths Support Programme website.